And it's going to be quick because we've already done it. We've done it with transformations. So we should know all of that. And then I'll do a little bit of work on the board to show you everything that happens. Okay, so first things first. I'm going to start by showing you where those sine and cos graphs come from. Okay, so I'm only going to use the first quadrant for this so that you get the gist of it, because again, we've already done this. Okay, now, okay, whatever you're playing with, put her away for now. All right, so here's how this works. The sine graph, if you recall from applied math, looks like this. Okay, so we drew the sine graph out like that. So now, looking at that graph, we talked about the maximum value being 1, the minimum value being -1. What's the amplitude of that graph?
2.
No, 1. The amplitude's the maximum distance from the D value, the midline, to the top or to the bottom. Okay? What was the period of this graph? How long did it take to repeat itself? Go ahead. So in applied, we did 360. Here we do 2 pi. Okay? Once around the circle. Now, where did the rest of these coordinates come from? Well, the rest of the coordinates come from your around the circle here. Okay? So at pi over 6, it's 1/2. Right? At pi over 4, it's root 2 over 2. At pi over 3, I'm cramming it in. Pi over 3, it's root 3 over 2. And at pi over 2, the halfway point, it's 90 degrees. So this is where it comes from. 1/2, root 2 over 2, root 3 over 2, and 1. And then I keep going around the circle. I go back to here, here, and here. That's how I get there, there, and there. And then down here, back to there again. And then my ratios, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, like that. So that's where the actual sine graph comes from. The cos graph is, of course, the same thing. The exception being, it starts up here, down here, 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 and here. Like that. So where does the cos graph come from? It comes from those ratios for the x value all the way around the unit circle. So that's where the sine and the cos graphs come from. Now we won't deal with tan today. We'll deal with tan after the break. But for right now, we have to go through and we remember what happens here. So we're okay so far. All right. We did this. Amplitude 1. What's the equation of the midline? Equation? y equals 0, right? Period, 2 pi. Okay, so all of that we already worked with and how we get to that point. Okay, so now the next step in this process, we also did this. Which we've been doing all along. So how does A change the graph? Well, what did A change the graph in any of the graphs we've done to this point? How did it change the graph? All right.
Vertical stretch, wasn't it?
Yeah, good. So what do? I mean, let's just go back to this again. Okay, so I get x, a, y, right? We times all my y values by that. Times all my x values by 1 over what the b is. Again, all this stuff we've done. And finally, there. So back to the same. So far, so good. Okay, now let's go to this here and let's have a look and see what's happening here. Okay, I need to do this. I'm going to change this to radians. So I'm going to make this minus 6.24. That's 6.24. That. Oh no. Yeah, that's right. Minus 5 plus 5. Okay. All right. So there's that. Now, here's what we're going to do. Y equals A. There. Function. Sine. B. So it's B. B. Bracket. X minus bracket. C. There. And then close bracket one more time. Add D. Do this. Okay. So there's the start of my sine graph. Okay. Now, I want my C to be 0. So I'm going to start there. My D is going to be 0 as well. So that starts there. Okay. So there's where A is equal to 1 and B is equal to 1. All right. So that is the equation of y equals sine x. So now let's look at what happens to the graph when I adjust some of these. So by adjusting A, what should happen to this graph?
Steeper.
Stretches out, right? What's the amplitude of that graph? 4. Easy peasy. Okay, so I stretch it. I get that to equal 4. All right, let's bring this back down to 1. Okay, right now my period is 2 pi, which is approximately 6.28. Okay, so how do I get my new period if I adjust my V? Do you remember? So A is my amplitude, right? B affects the period. My new period is 2 pi over whatever the B value is. That means it's going to repeat at 2 pi over whatever B is. So let's make that 2 now. So if I make that a 2, what is the period of that now? Yeah, 2 pi divided by 2, which is pi and 0. Okay? What happens if I make that 3? What is the new period going to be? Yeah. Two pi over 3 and 0. Okay, so that affects the period. All right, so let's put the period back to 1 now. What happens then? I change the C value.
Horizontal shift.
Horizontal shift. Okay, now I'm going to change this guy. I'm going to go minus 1. Oh no, I need 2 pi. Shoot. So it's going to be a little harder to do. Let's go with.
You have a pi button too.
Yeah, I do.
What are these just straight button?
I agree with you on that. Let's try it and see if that's going to give us what I need. Okay, so let's try this. Let's adjust this. Okay. Oops. Okay, so what's happening to the graph now? Okay, so right now, there's my starting point of my, so this is where I consider my starting point for my sine graph is on the midline when it goes up and to the right. Okay, so let's move this. What would that be? Pi over, let's go pi. So this is pi to the right. So now you notice right here, my whole graph moves pi to the right. Okay? So that's my C value, that's how it affects it. So I can go over here. Now I notice I move it to the left. And so on. Okay. What is the D effect on the graph? Vertical shift, but what does it affect? What part of the graph did we need to know something about? Yeah. It affects my midline. So right now my midline is y equals 0. Now my midline is y equals 3. Straightforward. Got me so far? Okay, so the first section of this is just some simple adjustments. And again, I don't think I need to really rip any more of these off. Let's look at, okay, let's go to page 152. Okay, so I need to change this. Cos. Okay, there's my cos graph. So what's the maximum value? 1. Fill in that chart, page 152. What's the maximum value? Corbin just said it. 1. What's the minimum value? Yeah. -1. What's the amplitude?
1.
What's the period? 2 pi. What are the x-intercepts of this? Where is y equals 0 here? There's your x-intercepts. Pi over 2 and 3 pi over 2. What you're looking for is when your y value is equal to 0 for the coast graph, right? So if I go my coast graph, y equals 0 right there, y equals 0 right there. I'm looking on a unit circle, all right? Where does y equal 0? Sorry, where does cos equal 0? That's what I'm looking for, not y. Where does cos equal 0? Right here and down here. Pi over 2 and 3 pi over 2. That's where cos theta is equal to 0. Okay? So that's how I get those two coordinates there. All right, because we're talking about cos. What is the y-intercept of this graph? It's what? 1. Okay. So can we fill in the blanks for this if I don't do anything on the board yet? What is the maximum value of y equals negative 4 cos theta? Maximum value? Was the maximum value here?
4.
What is it? What does a negative 4 do to the graph? What's the transformation? We got to be able to explain that. What is the transformation? By? Of negative 4. Okay, so you can say it that way.
Yeah.
But really there's two transformations there, isn't there? Vertical stretch by a factor of 4 and a reflection over the x-axis. So my a value is there. Okay? So does that change my maximum and minimum values? Yeah. Becomes 4 is my maximum. My minimum is negative 4. What's the amplitude? Still 4. What's the period? 2 pi. What are the x-intercepts?
Be the same.
Yep. They don't change. What's the only thing that I adjusted on that equation? My a, which affects what part of the graph? Yeah. X or y? Which one does it affect? It only affects the y values. So the x's stay the same, therefore the x-intercepts stay the same, therefore the period stays the same. What's the y-intercept in this graph now? Negative 4. Okay? Let's do okay, well let's do page 152. Let's start that together. What's the amplitude? 1a. Amplitude. 2. B. 1/4. C. 5. D. No. 3. Amplitude is the maximum displacement. It's an absolute value. Okay? So it is 3. The a value is negative 3. Okay. State the period of each trig ratio. Function in degrees and in radians. What is the period of y equals 3 sine theta?
2 pi over 3.
No.
360 and 2 pi.
360 and 2 pi. What's your b value, Corbin?
3.
That's a, dude. A is in front. Your b value is just 1. Right? Okay, now look at b, Corbin. What's your b value?
Wow. Oh wait. How is it? 2.
2. Right on. Okay, so now what's your period?
180 and pi.
180 and pi. Right? You're taking 360 divided by your b value. Let's go back to that. Look at what we did here. How do I get my period? 2 pi divided by b, or 360 divided by my b. Where's my b located? My b is always located in front of the angle. So in C, what's the b value? 0.25. What is your period for that one? What's your period for it? Somebody tell me what your period is.
1440.
1440? And?
90 degrees.
No, it can't be 90. How do we get it?
1480.
How are you getting that?
360 times 4.
Okay, 360 times 4. That's right. 360 divided by a quarter is 360 times 4. Now I got to go 2 pi. 2 pi divided by quarter. What do you get?
Wait, what? 25.1.
8 pi.
No.
2 pi divided by a quarter. 2 pi. You have exact
You can't. Right. Yeah, you can't.
8 pi.
8 pi. It's 2 pi times 4. There it is there. Look up here. What is it? 8 pi. Okay. All right. What about D? What about D? What about D?
240 and 4 pi over 3.
Okay. 4 pi over 3? Yes. And what was the other one?
240.
So 360 divided by 3 over 2 is times 2 divided by 3. Yes, I agree. Okay. All right. I would like you to finish actually 5.1 and 5.2. Although, okay, let's look at page 159 right now.
Oh, yeah, lots going
159. Here's what I want you to do to graph these. Okay? It's a lot of work. Now, I'm going to show you 2 ways in order to graph a trig function. And then it's up to you to decide which way you want. I'm going to show you first a newer way, which I think is the easier way to graph it. Or I'm going to show you the old way in which we list off the coordinates and then we just translate the coordinates. Okay? So it's going to take a little bit of time today. So I'm going to show you how this works. Okay. So the first thing that I do is I draw a line. That's going to be my midline. Now I'm going to put in my 5 key points depending on whether it's sine or a cos graph. So I need 5 key points. So it's a sine graph, so it starts here, goes up to here, down to here, there, and there. Those are my 5 key points. I would suggest you probably write this down. I wouldn't use a graph. I would put this kind of to the side. Put it somewhere.
How do you know where to put your midline off the start?
I'm going to tell you right away. So draw a line, which is going to represent your midline. Put your 5 key points. Now, if this was a coast graph, I would start up here at the maximum value. So this is all we got to do now. All right. Good so far. Okay, now there's an order in which you need to do this. You need to do this in a specific order. So again, it may not be the simplest thing for you to do, but I'm going to try it. So the first thing I do is I write down what my C value is. What is my C value? Look at the equation. Close. Negative pi over 2. So I go to negative pi over 2 right here. So I put that in. Are we okay so far? The second thing I need to do is I need to identify what my period is. So using B, what is my period for this graph?
1.
That's my B. So what's my period?
2 pi.
2 pi. Okay. 100% agree. Okay, so it's 2 pi. All right. So what I'm going to do is I'm going to add 2 pi to negative pi over 2.
I didn't know your period's 2 pi.
My B value is 1. Period. 2 pi over B or 360 over B. If there's no B value adjustment, how far around the circle does it repeat itself? What's once around the circle? Or 2 pi. Make sense?
Yeah.
Okay. So I'm going to find out when this graph here repeats itself. So I need to add 2 pi to that, which is 4 pi over 2. Agreed? What's negative pi over 2? Add 4 pi over 2.
3 pi over 2.
Very good. 3 pi over 2. Okay. So the third is to work with my x-axis here. All right. So now I need the halfway point. What is halfway between those two?
2 pi over 2. Pi.
Yeah, you're pretty close. Okay. The full was 2 pi. Agreed? Halfway is 1 pi. Yes? As a pi over 2, that's 2 pi over 2. Correct? So what's 2 pi over 2 add negative pi over 2? 1 pi over 2. So that's one way to do that. 2 pi over 2, subtract pi over 2. 2 pi over 2, subtract 1 pi over 2, because it's a negative.
Okay.
Or I could go 3 pi over 2, subtract 2 pi over 2. I'm going to get there. I'm trying to find the halfway point. The halfway point is add those two and times by a half. That also works. Okay? All right. I need the halfway point here now. I need the halfway point between those two. What's halfway between negative pi over 2 and pi over 2?
Pi over 4. 0.
It's 0. So wouldn't you know it? That's actually one of my axes. So I can draw my axes through here like this. It's 0. What's halfway between 1 pi over 2 and 3 pi over 2? Stop doing this in your head mathematically. Think about it. What's 1 pi over 2?
2 pi over 2.
And 3 pi over 2. So what is this value?
Which is straight up pi.
Straight up pi. Right? Make math simple. Make math simple. Okay. So there's the first thing that I had to do is I had to identify the axes. That x-axis. Now, at this juncture, okay, I've identified C, I've identified B. Now I just have to put in my y-axis, my values for my y-axis. What's my midline in this graph? Look at your equation. What's your midline? Y equals 3. So that is right there, 3. What's my amplitude? What's my amplitude for this graph? Just 1. So what's my maximum value?
1. No. 4.
4. What's my minimum value?
2.
There you go. Now the last thing that I do is that I put in my axes. And this can be roughly done. 4, 3, 2. My axes should be somewhere down there. And I've drawn out one period of that graph. Okay? All right, so this would be 1 here, and then 0. All right, so that is one way to do it. So I start by drawing my midline in. I put in my C value. I use my period to put the other 5 values in for X here. Then I find my midline value, my amplitude I use to get my maximum and minimum, and that's it. So that's actually the simplest way in which you can do one of these graphs. All right? The alternative to doing it that way is simply this. X, Y. Using the key points, the 5 key points of a coast graph. So the 5 key points of the coast graph are 0 and 1. I'm saying that because I'm gonna do it this way. So 0 radians and 1. So at 0 degrees or 0 radians, my coast value is 1. Up here, at pi over 2, and 0. Then I go to here. So that is minus pi. Sorry, it's not minus pi. It's pi and negative 1. 3 pi over 2 and 0 and 2 pi and 1. Okay, those are the 5 key points. Now, I need you to clear a spot here. Most people, most students, like using degrees better than radians. And for the transformations, it usually is easier to do. Okay, so you got to keep that in mind. You might want to use degrees. Eventually, you got to go back to radians, but you might want to use degrees to do it. Okay, so looking at the equation now, I'm going to write the equation down here. Y equals sine theta plus pi over 2 add 3. Okay. So to graph this, I go over here. A, B, C, D. What's my A value in that equation? 1. What's my B value in that equation? Also 1. What's my C value? Negative pi over 2. And my D value? 3. Okay. So this is where we're at right now. Got it? I don't have to do anything with A and B. They stay the same. So now all I'm going to do is C. So what do I do with C? Well, I add it to my X value, right? So I get negative pi over 2 and 1. 0 and 0. pi subtract pi over 2 is what? Pi over 2. Negative 1. 3 pi over 2 subtract that is pi. 2 pi, which is 4 pi over 2, subtract that is 3 pi over 2 and 1. So I have that so far. Now, I got to use the y. So what am I doing with the y? I add it to d, right? So I get negative pi over 2, 4. 0, 3, pi over 2, 2, pi, 3, 3 pi over 2, and 4. Now, they gave you a grid. What I want you to do is I want you to plot those 5 points on the grid right now. So plot those 5 points on the grid right now. You got a grid. Put those 5 points on there. That doesn't match up. Oh. No. What did we do wrong here? We got an error. Now, which side is the error on, the first graph or the second graph? First one. And midline is 3. Hold on. You got an error there. I'm not sure where it is. So D is 1. C is this. This. I'm going to go pi. No, it's negative pi over 2, right? C is negative pi over 2. Okay. And then that. Okay. So this.
It's supposed to be a sine graph. One doesn't do
Oh, this is cos up here, right? So let's change that to sine. So let's start there. Good. So I've got that there. Okay. So now this thing moved minus pi over 2 to the left, which is approximately negative 1.571. That's not right. Why is this not working for us? Oh. No. Oh, this is, okay, here's a problem. All right, that needs not to have a bracket there. That bracket here has to disappear. No, it keeps adding brackets here. There. There.
Only two after you see, right?
There we go. Okay, sorry about that. All right, so my midline, this graph should be right there. I need a tree. So negative 1.57 and 3 should be that. So we've got an error here. What is the error we made here? 0.
We put pi to 3. Look at the right side. Did we use the coast coordinates for the sine graph?
We 100% did. Yes, thanks. That is the error. Okay, well, let's make this bigger and let's adjust this. We totally did the coast graph here. So that's going to adjust these. Okay, thanks, Carter. Good pickup. And now let's fix my faux pas. So the sine graph is 0, 0, 1, 0, negative 1, 0. So that still makes that 0, 1, 0, negative 1, 0. And then over here, that would be 3, 4, 3, 2, 3. There we go. New one there. So we have to adjust that. So that is the mistake we made. We did a coast graph instead of a sine graph on the right, and on the left it's correct. And now we're back to where we need to be. Okay? So on this graph here, that matches up. There we go. We got our points there. And then if I were to do this, I would maybe put a midline in of y equals 3 just to see it. Now that I have that midline in, that gives me that there. And it shows it to me as negative pi over 2 and 3 now, which is exactly where we started right there. Okay? All right, so basically what we are going to do for the next till Friday, we're just going to focus on sine and cos. It's going to take you some time to get used to this. So we're going to do sine and cos this week. So tomorrow and Friday we'll work on that. Okay? The tangent graph we won't touch right away. Okay? Any questions? Probably none until you get kind of started with it.